Standard form, it's a funny one, and these questions are very badly answered in an exam. So let's find out why, and let's hopefully, with a little method help, make these questions a bit easier. These numbers are all standard form. These are scientific constants. This one is the speed of light in a vacuum, meters per second. This one is how many molecules in a mole. Interesting stuff, but they all have one thing in common. P times 10 to the q, a number times 10 to a power. Standard form consists of a number multiplied by a power of 10. Well, that's just repetition. The number P, say, must be such that it falls between 1 and 10. And this is an equals whatever here. So that means P can be 1, but it cannot be 10. The power of 10 must be an integer. Well, that's a sort of easy one. There are two common questions. One, numbers to standard form and standard form to numbers. So that's a relatively easy one. One mark for that. This is a harder one, 2 or 3 marks for this little gem. Standard form multiplying or divided by another standard form number. This was 90% of the questions you'll get. So let's do it. Numbers into standard form. Write the following in standard form. That's 525,000. And we're looking for something like this. I always like to think about what I'm going to targeting. P times 10 to the q. There's my number. P is going to be 5.25. I just know that. Has all the information I need, plus it's between 1 and 10. We need to find a power of 10. So I'm going to add a decimal point here for clarity, and then I'm going to count how many times does the decimal point move to the left until I get 5.25. 1, 2, 3, 4, 5. The decimal point was there. This would be 5.25. 5. I count 5 moves to the left, so Q is equal to 5. 525,000 is equal to 5.25 times 10 to the 5. This works. You can check it in your calculator if you don't believe me. Let's go the other way. Write the following in standard form. All right. That's a nasty little number, isn't it? Okay, I don't like the negatives. We need something in the form P times 10 to the q. So there's my number with a decimal point. P is going to be 4.5. You just know it really. That's all the information from the number between 1 and 10. We need to find the power of 10. And how many times does the decimal point move to the right to give 4.5? So we start from here. 1, 2, 3, 4. So I count 4 moves to the right. So Q is minus 4. Why do I know it's minus? Because this is a small number. I don't do things about moving left and right. It's just obvious, isn't it? It's a small number. So it must be multiplied by a small thing, and 10 to the minus 4 is very small. 4.5 times 10 to the minus 4. Let's do a multiplication. This is the easy one. Multiplication is so much more easy than division. It always is. The important thing is that you keep the numbers 4 and 3 separate from the powers of 10, at least for now. If these are P's and these are Q's, you've got to mind your P's and Q's. But you can see that coming. Right, here we are. So you can see this is just a long run of multiplications, so we can move them around and the value won't change. We can group the 4s and the 3s, and we can group the powers of 10. 4 times 3 is equal to 12. And if you remember, you add the indices, don't multiply them, and that equals 10 to the 8. Problem, that is too big. This number has to be between 1 and 10. And the solution, and this really is magic, divide the 12 by 10 and add 1 to the power of 10. So we need to keep this number the same, but we need to get this down below 10. So 12 times 10 to the 8, I divide that by 10, 1.2, and I add 1 to the power of 10. So this is 10 times bigger, this is 10 times smaller, and these two numbers are the same. More work for your calculator if you don't believe me. That is in standard form. Right, let's have a look at the nasty one. I think this is the nasty one really, the division. Certainly sends people crazy, this one. Should it send it crazy? Well, the important thing, again, keep the numbers separate from the powers of 10, at least for now. So we're just going to show this as a fraction. That's just the same thing. And you can see now that this is, well, can be separated into two fractions, really. 3/4 times 10 to the 3/10 to the 5. Now it's looking easy. As I say, keep the numbers separate. So 3/4 is equal to 0.75, 3/4. This one, we're dividing by 10 to the 5, so we subtract this indices from 3. 3 minus 5 is equal to -2. So this is 0.75 times 10 to the -2. But I guess you've spotted it. This is too small. It has to be between 1 and 10. So this is the magic. Multiply 0.75 by 10 and now subtract 1 from the power of the 10. We need to keep this number the same. So if I make this 10 times 2, 10 times larger, I have to make this 10 times smaller. So I have this 10 times larger, and I have reduced the index by 1. Now, this is the horrible example, really. -2 minus another one is -3. People get this wrong, and I'm not surprised. At first glance, it looks like this is getting bigger, but it's not. It's smaller. It's more negative. But this is standard form. Right. So what do you do? I always recommend people have a little think. What am I trying to do? Sometimes it isn't obvious with a standard form question. Sometimes it's a little bit disguised. But once you know what you're doing, keeping the numbers and powers separate. This is always a slipping point. So mind your P's and Q's. I love it. Do the calculation. And then adjust your answer to standard form, because your P has to be equal to 1 but greater and less than 10. And then that just requires you to alter the P and adjust the power of the 10. And then check your calculation. This is tricky. This is tricky. There's no doubt about it. It's very bad, poorly answered. I hope I've made it a bit easier. It's still going to be tricky. Practice will assist. So if you've enjoyed this video, or even if you haven't, why not subscribe for more of the same? If you're taking an exam shortly, best of luck.